does not exist. So I am again saying what I have done from the beginning. I have chosen all the metric. I have written them. I have chosen the maximizing player, and from the maximizing player's perspective, I have chosen this particular game. I have we have written this the values of the game, and from the minimizing player's perspective, we have written the values of the game. So perspectives are different, but maximizing player have been put on the left of the matrix, and minimizing player have been put on the top of the matrix in both the cases. We have not changed the position, but what we have seen that in the first matrix, that is matrix 1, the positions, the diagonal positions were 0, and according to the rule of the matrix, we got +1 and -1 in some places. But since the perspective of the game has been changed in the matrix 2, so diagonal remained the same, but +1s of the matrix 1 have become -1, and -1s of the matrix 1 have become +1. So it is obvious that if we add the two matrices M1 and M2, we get M1 plus M2, and that becomes the null matrix. And it is true for all such matrices. Since two players are involved in the game, this game is called two-person game. And the loss of one player, since the gain of one player, gain of one is equal to loss of another, and there, since the sum total is 0, so this type of game is called two-person zero sum game. To find whether the value of the game exists or not, we calculate nu plus, which is the maximum of all row minimums. Sometimes we call it as maximin, and we calculate nu minus, which is called minimum of all column maximums. It is called minimax. So we have considered this row minimums over here, and the column maximums from there. Row minimum means you have to consider each element and choose the minimum one. Column maximum means you have to select each element and choose the maximum over here. And during the process, we have found that maximum of all the row minimums are -1, and minimum of all column maximums are +1. Since they are not same, therefore value of the game does not exist. But the definition says that if the value of the game exists, then that value must exist in a cell of the matrix. That cell will be called the saddle point. Here, in this particular rock, paper, scissors game, the saddle point does not exist. Any question?
স্যার একটা কোশ্চেন আছে।
Yes, tell me.
স্যার আগের পেজটাতে একটু যান।
Yes.
স্যার আগের পেজটাতে সেকেন্ড ম্যাট্রিক্সটাতে স্যার আপনি যদি ম্যাক্সিমাইজিং এ ধরেন, তাহলে তো স্যার ম্যাট্রিক্সটা এরকম আসবে না। তাহলে ম্যাট্রিক্সটা স্যার স্যার তো আগের ম্যাট্রিক্সটা চলে আসবে তাহলে।
No. Carefully observe. Are you comfortable with matrix 1, M1?
Yes sir, yes sir.
Yeah. Matrix M1, what we have seen that that we are seeing the matrix from player 1's perspective. Player 1 means maximizing player's perspective. So if you are seeing this matrix, you know that this particular amount player A is going to gain, and this particular amount which player A is going to lose.
Yes,
the
sir.
same metrics have been written from player B's perspective. So I have put this direction. So you see, in two-person zero-sum game, if one player loses, the other player gains. So if this is the loss of player A, that is the loss of player, this is the gain for player B. This is, let me write it over here, you will understand. If this is the loss of player A, then in the second matrix, we are seeing that this is the gain of B. If this is the gain of player A, then this is the gain of this is the loss of player B. So this is player B's perspective, and that is player A's perspective. But if you change, if you take this player B and put it over here, by the development of game theory and the rule set this player B will be treated as maximizing player if you change his position, because it has been told to us by the developers of game theory that you always put the maximizing player on the left of the matrix. Do not put him on the top of the matrix. So what initially I did wrong, I put B on the left, but as Kostov rightly said that, sir, if you just interchange the position of the two, the matrix is not going to change, because then in that case B becomes the maximizing player, because you have already told us the matrix remains the same. That should not be the case. Do not change their position. You are placing myself and Shubhashish on two chairs, but sometimes you are supporting me, sometimes you are supporting Shubhashish. It is not like I am taking the class and Shubhashish is on the other hand. Sometimes you are agreeing with his logic, and sometimes you are agreeing with my logic. Are we changing our position, that I am going inside the this portal and he is coming to my place? No, we are sitting in our places, but sometimes he is gaining and I am losing, sometimes I am gaining and he is losing. So that is the thing. Is this clear to you?
Yes, sir. Yes, sir.
Okay, okay. Now let me show you something. Let me see the page in which it is written. uh, just a minute, I'm just scroll uh, yeah, okay. Now I am stopping this share and I am going to show you the page of one of the pages of the book. So where is that? Okay, now you do one thing. Before you write question number 2, you write this part, page number, okay, page number 11. Okay, you write this part, you write this definition. I am reading it out for you. This definition says that, write it, a matrix game with matrix A n cross m. Matrices are always denoted by this notation, capital A. N cross m means it is the matrix order. Here the matrix order was 3. The number of rows and number of columns were same. It is not that should always be. The number of rows may be different from number of columns in general. Now, but that will not happen for two-person zero sum game. So in general, they are stating the definition. Therefore, they are choosing n number of rows and m number of columns, because they are stating a definition. Okay, they're stating a definition of something. So therefore, they have considered the general case. So this is the matrix, and the matrix has the lower value, that is nu minus. It is called max of mean of Aij. All the elements have been chosen. Aij's have been chosen over here, and J has been run from 1 to m. J is the column and I is the row. J is the column and I is the row. So first of all, think about the matrix which you have in front of you. That when we calculated row minimum, what did you do actually? You scanned the matrix column wise and you selected -1 from 0, 1 and -1. So you are scanning the matrix column wise. So therefore, they have written from J 1 to M. Once your scanning is done, then you scanned it row wise. Okay, max min, max of all row minimums. So you're scanning it from top to bottom. Scanning from left to right, that is column wise scanning. That is being done over here. Then after you get all the row minimums, you are scanning it from top to bottom, the column maximum. So not column maximum, top to bottom, that means maximum of all row minimums. So therefore they have written max I from 1 to n, min j from 1 to n. So here they are actually writing it in this way, but we will move in that way from right to left. We will do all the minimums first and then we'll find the maximum. So that is termed as nu minus, and upper, that is sometimes also called lower value. And it is here you are selecting all the column maximums. Okay, so you are seeing it row wise first. So therefore they have written I1. You are seeing it from top to bottom, top to bottom, top to bottom. And then you are selecting all the column maximums from left to right. And then you are selecting from left to right. And then you are selecting mean of that. So therefore here mean comes later. Max comes first and mean comes later. And therefore they have written as, they have called it as upper value. And this is denoted by nu plus. The lower value nu minus is the smallest amount that player one is guaranteed. You don't have to write it because the book is already with you. The lower value nu minus is the smallest amount that player one is guaranteed to receive, and the upper value nu plus is the guaranteed greatest amount that player two can lose. Okay, the game has a value if nu minus equal to nu plus, and we write this the value, the common value, as nu, or sometimes we call it as nu of A, means value of the game of the matrix capital A. This means that the smallest max and the largest mean must be equal, and the row column I star j star giving the payoff. I star j star means the cell in which this value will exist. That cell will be optimal cell, and that is called the saddle point. So entire thing which I have shown you through an example, it has been written with the mathematical notation. Probably we have understood why am I seeing this, why am I showing this particular concept through examples, because if I ask you to read it first, then you will be just lost in the notations, vast avalanche of notations of the avalanche of mathematical notations. If any one person sees this thing first, okay, so he will be afraid. So therefore I actually started with the problem. Now you, if you carefully read the definition, I am not discouraging you to read the definition. You have to read the definition, keeping in mind the rock scissor paper problem. Okay, so I'm stopping this share and I'm going back to my white screen once again, because we are all comfortable with the white screen. Even I myself comfortable with the white screen. I try to always my objective is to first do the problem. See, problem is not done. That means if you read a book, that is not reading. You have to solve the problem. And also, that is one important thing you have to keep in mind. These strategies, rock, paper, scissor, according to this chapter, these strategies are called pure strategies. They are called pure strategies. Okay, acha. That is another term which we shall be often using in game theory, pure strategies. The matrix elements. What are the matrix elements? 0, -1, 1. These are the matrix elements. You see, these are the matrix elements. These matrix elements are called, payoffs. This is another term we shall be often using, pure strategies and payoffs. Okay, so you have to keep this in mind also. The matrix elements are called payoffs. These strategies are called pure strategies. Value of the game is also a kind of payoff. Value of the game is also a kind of payoff, because it is nothing but one of the values from all possible payoffs. Okay, so value of the game is also a kind of payoff. Now I am again stopping the share, and I am going to show you the matrix which that question which was in 1.2. Let us go back to that so that you can copy it, so that I feel comfortable in discussing that particular problem. So I'm stopping the share. Now let us go to the page number 14, and let me give you some time to copy Let me give you some let me give you some time to copy both the questions 1.2 and 1.3. You copy it. Okay, I'm waiting for, I'm giving you time because the time is also running out. I'm going to start doing this problem I'm going to discuss the problem in the next session, not now, not in this session. But if you are done with copying 1.2 and 1.3, then you can start solving it. You can start thinking about how to write a game matrix for that. Okay, do not ask me anything. I'm going to discuss it in the next session. If you have not copied it, copy it, both these problems 1.2 and 1.3. If you are finished copying but time is still there, start solving it. Start to try to find out the game matrix. If you are able to find the game matrix, then you can find the you can try to find the value of the game and saddle point. But I shall suggest you not to look at the solution of the exercise. All the solutions are not given in the exercise. For your kind information, I'm saying. So uh, do it by yourself if you want to learn the subject. Okay, so do it by yourself. And game theory, I think, one of the most important subject of uh, you have to learn game theory very seriously. Okay, on a serious note, probably you have heard about Professor John Nash, and probably you have seen the movie A Beautiful Mind. That was on the life of John Nash, and probably you have read the book also, A Beautiful Mind by Sylvia Nassar. Okay, on which the movie was made, which starred Russell Crowe. Now that movie, if you have seen that person, if you know John Nash, he was the economist, Nobel laureate, and he got his Nobel Prize in economics for Nash equilibrium, which is one of the most important topic of game theory, and it is there in the Baron's book, but unfortunately not in the syllabus. So if you have the book, and if you sometimes in your life, if you think that, okay, I have to know what Nash equilibrium is, then I'm referring this book to you, and you can discuss anytime with me. Okay, this particular chapter is also very important in economics, the topic of economics, because actually Nash equilibrium is often used in economics, and Nash got his Nobel Prize for this. Okay, so that's why I'm saying that game theory is very important. It is far more interesting than transportation and assignment. Too, if you ask, because I find it more mathematical than the other two. So do not ask me anything right now. If you have finished copying, start with 1.2, question number 1.2, and try to find a game matrix. I shall do it in the next session. I shall do one of the problems in the class. As I can see, the time permits me. Either 1.2 or 1.3, and we can continue our discussion to the next class also. So because if I want to show that thing also to you, the software related thing, then I have to discuss one problem of these two. So we shall do it in the next session. Okay, 2 minutes 12 seconds is left for this particular session, and let us wait for the next session to begin. Okay, have you by the way, have you copied the question?
Yes, sir.
Okay.
Yes.
Yeah, okay. Can you see this? Can you see my screen now? The thing I am writing?
No, sir.
No.
Only the PDF is open. Only the PDF is open.
Only the
You can
PDF.
see the PDF only.
Oh, only PDF. Okay.
Hmm.
All of you try, keep on trying, finding out the matrix. Do not look at the solution. Do not try to find the solution from the book or from the Google.